So the first concept we want to talk about today is sequences, and sequences are something that you've probably seen before. You maybe just haven't quantified them and turned them into number expressions. It's basically like where you're given 3 or 4 numbers in a row and you're asked what number comes next. That's essentially a sequence. You're following a rule to come up with the next number in that sequence. So more formally, a sequence of numbers is an ordered list. It can be infinite, go on forever, or it can be finite. And each number is a term in that series, or in that sequence. And each term is defined by the rule a sub n. And essentially, you'll have terms like a sub 3 or a sub 20 if you wanted to. And all that means is that you're looking at the third term in that sequence, or the 20th term in that sequence. So let's go ahead and do an example. So let's say you had the numbers 100, 200, 300, 400, 500. They're like, this is a sequence. Can you define a rule that uses the number that term is? So a sub 1, a sub 2, a sub 3, a sub 4, a sub 5. And come up with a rule for the next number. So you may be noticing that each of these numbers is the term times 100. So 2 times 100, 3 times 100, and I can't write today, 4 times 100, and so on, right? So each term, first term, second term, third term, fourth term, fifth term, is the term number, which we denote as n, times 100. So the sixth term, a sub 6, would be 100 times 6, or 600, which would be your next guess, right? So we have this function, or this rule, that says the next term, a sub n, is going to be 100 times the term number it is. Now, one thing I do want to note before we continue on, it's very important that you realize that n has to start with 1. It does not start at 0. So please do not make that mistake. I've seen that a couple times. Always start at 1, and it is always a whole number. Okay, 1, 2, 3, 4, 5. You can't have like term 5.5. No, we're not going to do that. So just whole numbers. Okay. So let's go ahead and write the first 5 terms for the rule or the sequence a sub n equals 2n plus 1 over n squared plus 1. So I like to just write out a sub 1, a sub 2, a sub 3, a sub 4, a sub 5. Then we're just going to fill out each one. And all you're going to do is replace the n with the number of that sequence. So the first one, n, would be 1. So it'd be 2 times 1 plus 1 on top, 1 squared plus 1. So that would get you 3 over 2, so 3 halves. A sub 2 is going to be 2 times 2 plus 1 on top, and 2 squared plus 1. Got to write a little smaller, so that'd be 5 over 5, which gets us 1. A sub 3, we're looking at the third term now. So 2 times 3 plus 1. Again, I'm just following this rule and plugging in for my n. 3 squared plus 1. So what does that give us? 7 over 10? 7 tenths. Okay, let's do it for a sub 4. And it's just kind of like plug and chuck, right? That's all we're doing here. So 2 times 4 is 8, plus 1 is 9. Let's see, that'd be 16 plus 1 is 17. And last but not least, we have our final 5th term. So 2 times 5 plus 1 over 5 squared plus 1. So this would be 11 over 26. So you would have the first 5 terms. We could go ahead and write them out in order. So it'd be 3 halves, 1, 7 tenths, 9 over 17, and 11 over 26. There you go. There are our first 5 terms in this sequence. Now, this is an infinite sequence. It would go on forever, but they only asked us to find the first 5 terms. Okay, let's try to go the other way. Let's say we're given a sequence and we have to guess the formula. It's kind of a fun thing to do. So you always start off with your a sub n. Okay, that tells you each term is going to have this formula. So we look at what's happening, what's the pattern here. It looks like every other term is switching the sign, right? That's the first thing. So every other term is switching the sign, right? And then each term is just that number, right? 1, 2, 3, 4, 5. So we're not even multiplying by anything. So we know n has to be in there, right? N is the term, 1, 2, 3, 4, 5. But how do we get that negative? So the first term is negative, the third term is negative, and the 5th term is negative. So it appears that only the odd ones are negative. Well, if we multiply by -1, right, that's going to make all of them negative. So that's not going to work. So what could we do to manipulate that negative to only work when it's an odd? What if we raised it to the nth power? What happens? Well, -1 raised to the first power stays negative. But what happens when we raise it to the second power? -1 times -1 turns into a positive. So you end up having a +1 times 2, or just 2. And you'll see when it's odd, it stays negative, and when it's even, it turns into a positive. So that actually helps to take care of it, and this would actually be the formula. That one was a little bit tougher. If you got it, pat yourself on the back, because that's a really tough one. If you didn't get it, that's okay. We're still practicing. It's good to look at it, and the more you see solutions to problems, the easier it's going to be to come up with that solution. So stay positive, just stick with it. So we talked about sequences, what they are. Now there's a couple different types of sequences that we need to discuss. The first one is a convergent sequence. Now a convergent sequence occurs when the terms are getting closer and closer and closer to some real number. Now this may sound familiar. It may sound like asymptotes, right? You had that invisible line and they were getting closer and closer to the value. It's the exact same thing. When you're looking at a sequence, and if you were to graph the results, you would notice that it gets closer and closer and closer to a certain value. That horizontal asymptote, right? So for example, the sequence a sub n equals 1 over n is a convergent sequence. Why is that? Well, if you were to graph 1 over n, just grab GeoGebra, it's our favorite, you would see that it starts to, as the numbers increase, right, it starts to converge to 0. We also had that rule when we talked about asymptotes, that when your exponent on the bottom is larger than the exponent on top, you have a horizontal asymptote at y equals 0. I know that was a couple weeks ago, so it may not be as fresh in your mind, but just note that if we did graph it, notice that it gets closer and closer to that 0. In fact, you could graph more points if you'd like to see that it gets closer and closer to 0. So we say that it converges to 0. So let's go the other way. Instead of convergent, let's do divergent. Now, divergent has nothing to do with the movie, okay? The very popular movies. Eventually I'll start to date myself, but divergent does not have anything to do with those movies or books. So instead it's saying if you're not convergent, if you're not approaching a line, okay, or approaching one value, you're going to be divergent, the opposite. And essentially what that means is your numbers are just going to keep on increasing, keep on going up, okay, keep on. So Here's an example of a divergent sequence. A sub n equals n squared. Why is it divergent? Because if we look at the terms, so 1, 4, 9, 16, 25, 36, 49, 64, do we see an end in sight? Is it leading us to one answer? No, it just keeps getting larger and larger and larger. So that's why it's divergent rather than convergent, okay? Keeps on going, keeps on getting bigger. Okay, so that is your information about sequences. In a second, you should be watching the video on series, which takes that information and builds on it. So keep on going. We only got through the first part.